Hi everyone, welcome to our channel IPM Leap. Today's video is on a very special maths topic which is a favorite of question setters in entrance exams. We are going to discuss the method for solving special linear equations with integral variables. To be frank, this topic is not rocket science. Simply that it is not a part of math syllabus at schools, and that is why most students don't know how to solve such special equations. In this lesson, we are going to uncover the basics while solving the 4 questions that you can see on your screen. I hope by the end of this video, you will have learned how to tackle such questions comfortably. Do take notes as you go along this chapter. Let us begin. So friends, let me give you an example scenario to understand what is a special equation. Look at this boy. His name is Garv. He purchased a certain number of pencils and a certain number of erasers, spending a total of rupees 100. If each pencil costs him rupees 3 and each eraser costs rupees 4, then how many different combinations exist for the number of pencils and erasers that he bought? How do we go about solving this question? Well, we take some variables and formulate equations on the given data, isn't it? So let us suppose the number of pencils bought are equal to x and the number of erasers bought are equal to y. Each pencil costs rupees 3, so total money spent on pencils is 3 times x, right? And each eraser costs rupees 4, so total money spent on erasers will be 4 times y. Total expenditure is given to be 100 rupees. So we can use this information to write the equation 3x plus 4y is equal to 100. Now if our variables x and y could take any real value, then please make a note. A single linear equation in 2 variables always has infinite solutions. Why? Because you can take an arbitrary value for one of the variables and find the corresponding value of the other variable such that the equation is satisfied. Let me give you some examples to understand what I mean. So suppose we take x is equal to 22. We get the value of y from the equation as 34 upon 4, which is equal to 8.5. For some different value of x, we will get yet another value of y. For example, if we take x as 13, from the equation y comes out to be 61 upon 4, which is equal to 15.25. Any such combination of values of x and y for which the equation holds is called a solution of that equation. But now comes the important point. Even though the question does not mention it explicitly, but our variables x and y must take only integer values. Why so? Because the number of pencils or erasers has to be a countable number, isn't it? The minimum quantity that you can buy for any of these items could be 0, and then you can buy 1 or 2 or 3 or 4 or so on. Any number in between is not allowed. This boy Gav cannot buy 4.3 pencils, for instance. He can either buy 4 pencils or 5 pencils, but not 4.3 pencils. Hope this point is crystal clear now. So a quick overview of what we mean by the term integral solutions. This term has 2 parts, integers and solutions, so I will briefly touch upon both of them. Well, all countable numbers such as 1, 2, 3, 4, we also call them natural numbers. They are called positive integers. Add to this the number 0 and we get the set of non-negative integers. Add to these their negative counterparts, numbers such as -1, -2, -3 and so on, and we get the complete set of integers. So we have to be careful while counting our solutions. Double read the question and see whether it mentions positive integers or non-negative integers or any integer that is allowed as a solution. Next, we come to the second word of this term, which is solutions. Well, as we mentioned earlier, any combination of x and y for which the equation is satisfied is called a solution. For example, if we take x is equal to 8 and y is equal to 19, let us put these values in the equation and see if it holds. So, 3 into 8 plus 4 into 19 is indeed equal to 100. So, this is an acceptable solution because for this combination, the variables are integers as well. We call this an integral solution. But we would like to know exactly how many solutions exist. That's a question, right? And to get our answer, we have to solve this question. One more point to remember is that in most questions, whenever there are such special constraints for variables that they must take only integer values as solutions, we have only a finite number of solutions. We can count the number of solutions on our fingertips. And in this video, we are going to learn how to list down all possible solutions in the quickest and the easiest manner possible. For now, let me rephrase the same question for you. Did you realize it's the same question? Only this time the question specifically mentions that the variables x and y have to be natural numbers. With this introduction, let us discuss how to solve our first question, which is to find the number of ordered pairs of natural numbers x, y satisfying the equation 3x plus 4y is equal to 100. And there are some options. So one of the most intuitive methods, let me call it method 1, is trial and error. Everyone who is trying special equations for the first time should know this method because in many questions, we can find our answer by simply using this method, nothing more. Now see, since our variables are natural numbers, we can try out different values of any one variable, say of x, and find the value of the other variable y from the equation. Smallest value x can take is 1 because the smallest natural number is 1. So if we take x is equal to 1, we get value of y as 100 minus 3 divided by 4. 97 upon 4 is 24.25. But in this combination, y is not an integer. So we have to drop this solution. Next value that x can take is 2. After 1 comes 2. So for x is equal to 2, y is equal to 100 minus 6 divided by 4. 94 upon 4 is 23.5. Again, in this combination, y is not an integer. So, we must drop this solution as well. Next iteration, x is equal to 3. For x is equal to 3, y is equal to 100 minus 9 divided by 4. 91 upon 4 is 22.75. Y is not an integer. So, this solution also we have to drop and we move to the next iteration. As you can see, in these iterations, we are trying out different values of x. 1, 2, 3, 4 and so on. We started with the smallest permissible value which was 1. Let us take x is equal to 4 and fingers crossed. For x is equal to 4, y is equal to 100 minus 12 upon 4. 88 upon 4 is 22. Bingo, we have arrived at a solution because in this combination of x and y, both are integers and together they satisfy the equation. But now, after this exercise, I am sure you understand the drawbacks of this method. This method is very time consuming and calculation intensive. The method is still okay if we need only the initial solution, but the truth is we need all the solutions. And I just can't afford to do 30 to 40 iterations during exams. So let us move on to method 2. And I am sure now that you understand the drawbacks of method 1, you will appreciate the beauty of our upcoming method even more. In method 2, we simply rearrange the terms of the special equation and write it in a specific format to make our calculations and our iterations simpler. For this, we take the variable with the larger coefficient to the right hand side. 3 versus 4, 4 is bigger. So we take 4y to the right hand side. So the equation can be rewritten as 3x is equal to 100 minus 4y. And 4 you can take common from both terms. So 3x is equal to 4 times 25 minus y. Now divide both sides with the number 3. We get x is equal to 4 into 25 minus y whole upon 3. What next? Remember, x has to be an integer. This will happen only when the numerator of the right hand side is divisible by 3. Since 4 is not a multiple of 3, so that means this term 25 minus y should be a multiple of 3. Only then x can be an integer. Further, from this revised equation, it is easy to do iterations. Let me highlight the revised equation and the objective of our iterations, which is 25 minus y should be a multiple of 3. If y is equal to 1, 25 minus y is equal to 24. It's a multiple of 3. 3 eighths are 24 and 4 eighths are 32. Bingo! We have our first solution in which x is equal to 32 and y is equal to 1. Let us list it down. Also, it's easy to see from this equation that this term 25 minus y will be a multiple of 3, which means it will be divisible by 3 if and only if we take y is equal to 4 or y is equal to 7 or y is equal to 10 or y is equal to 13 and so on till y is equal to 25. Beyond this, x becomes negative. Let us quickly list down our corresponding values of x using this revised equation. X is equal to 28 here, 24 here, 20, 16, 12, 8, 4 and 0. But x has to be a natural number, so we drop the last solution. And there are 8 solutions possible. 8 ordered pairs of x and y that satisfy this equation. Now in this question, we can make 2 very important observations which will help you in subsequent questions. Did you note that when x increases, y decreases and vice versa? This happens in all special equations where terms with variables have a plus sign in between. Like in this case, it was 3x plus 4y, plus sign in between. Understandably, sum of two terms is a constant. So if one of them increases, the other decreases and vice versa. Next important point to note is that from one solution to the next, x decreases by the coefficient of y and y increases by the coefficient of x. Let me reveal the secret to solve all special equations. This pattern is followed by all special equations. So the only effort required at our end is finding out the initial solution, because from one solution to the next we can use this pattern to draw the list, and that's the trick of doing these questions super fast. One more point that I wanted to highlight. What if there is a minus sign instead of a plus? For example, if they ask you how many integral solutions exist for the equation 3x minus 4y is equal to 100 if x and y are greater than 0. How does our answer change? So friends, remember the basic steps to rewrite this equation remain the same. We get x is equal to 4 times 25 plus y whole upon 3. For x to be an integer, 25 plus y should be a multiple of 3. I can see this happening when y is equal to 2 and further when y is equal to 5, y is equal to 8 and so on. X turns out to be 36 for this, 40 for this, 44 for this, and we can extend this list. So the only change is x and y move in the same direction. When x increases, y also increases, and when x decreases, y also decreases. The second inference still holds. That is, from one solution to the next, x increases by the coefficient of y and y increases by the coefficient of x. And let me repeat, this is true for each and every special equation when it is in simplest form. So now that we have understood this wonderful scheme of solving special equations, let us try out the question on your screen. What are the number of integral solutions of the equation 7x plus 4y is equal to 130 for x and y greater than 0? Options are 2, 4, 5, 7 and infinity. Through this question, we will discuss the various steps involved in solving such questions. But if you trust me, let me show you how to get the answer within seconds. As I said earlier, we have to only find out the initial solution through iteration, and then we can use the pattern that we discussed and list down other solutions comfortably. Smallest value of x is 1. For x is equal to 1, y is equal to 130 minus 7 upon 4. 123 upon 4 is clearly not an integer. Next, let's try out x is equal to 2. For x is equal to 2, y is equal to 130 minus 14 upon 4. 116 upon 4 is 29. Great, we have a solution here. X is equal to 2 and y is equal to 29. Now remember, as we learned in the previous question, when x increases, y decreases. And from one solution to the next, x increases by 4 every time, which is the coefficient of y, and y decreases by 7 every time, which is the coefficient of x. Let us use this to list our further solutions. 6, 22, 10, 15, 14, 8, and 18, 1 are the other solutions. We need not increase x further as y will become negative. So, there are how many solutions? There are 5 solutions for this question. But sometimes it is not so easy to find even the initial solution. Especially when the coefficients are bigger, we might need 8 to 10 iterations even for the initial solution. Rewriting the equation in a specific format helps in such cases. Here are the steps to do that. First, we take the term with the bigger coefficient to the right hand side. So 4y is equal to 130 minus 7x. Next, it's easy to see that left hand side is 4 times something. It's a multiple of 4. So for the equation to balance, the right hand side has to be a multiple of 4 as well. So on the right hand side, we extract all multiples of 4. 130, the nearest multiple of 4 is 128. So we write 130 as 128 plus 2. And minus 7x, we split it as minus 4x minus 3x. This ensures that we have extracted maximum multiples of 4 from the right hand side. Next, we divide the equation by 4 on both sides. In general, we divide by the coefficient on the left hand side, which is 4 here. So by design, these two terms are multiples of 4. We simplify the equation. Y is equal to 32 minus x plus 2 minus 3x upon 4. This is our revised equation. In the final step, we have to find the initial solution first. And this should be a much simpler task now that we have the revised equation. Look at the revised equation carefully. If x and y are integers, then left hand side is an integer. This is an integer. And so for the equation to balance, the fractional part of the equation, which is 2 minus 3x whole upon 4, should be an integer too. So 2 minus 3x should be a multiple of 4. Iterations become very quick now. If x is equal to 1, 2 minus 3x is equal to minus 1. Not possible. If x is equal to 2, 2 minus 3x is equal to minus 4, which is a multiple of 4. So we have arrived at our initial solution. Putting x is equal to 2 in this equation, we get the value of y as 32 minus 2 minus 1. That is, y is equal to 29. Rest of the process remains the same. Using the pattern that a special equation follows, we list down all other solutions as well. So now that you have understood the steps, let's try out another question. How many integer solutions exist for the equation 8x minus 5y is equal to 221 such that x into y is less than 0? And there are 4 options for our answer. Now this condition that x into y is less than 0 simply means that x and y are of opposite signs. If x is greater than 0, then y must be less than 0. And if x is less than 0, then y must be more than 0. So let us rewrite this equation in a workable format first using the steps that we have learned for special equations. First, we transfer the term with larger coefficient to the right hand side and we get 5y is equal to 8x minus 221. Now the left hand side, which is 5y, has to be a multiple of 5. So let us extract the obvious multiples of 5 from the right hand side as well. 8x can be written as 5x plus 3x and minus 221 can be written as minus 220, which is a multiple of 5, and minus 1. Now when we divide both parts of this equation with 5, we get y is equal to x minus 44 plus 3x minus 1 whole upon 5. This is the required format. In this revised equation, y and x are integers, minus 44 is an integer. So for the equation to balance, this fractional part, 3x minus 1 upon 5 should be an integer too, which means 3x minus 1 should be a multiple of 5. Now let us find our initial solution. If we take x is equal to 1, 3x minus 1 is equal to 2. 2 is not a multiple of 5. So we drop this value of x and move on to the next possible value. X is equal to 2. For x is equal to 2, 3x minus 1 is equal to 5. Bingo, we have arrived at an initial solution here. For x is equal to 2, y is equal to 2 minus 44 plus 1. Y is equal to minus 41. This solution satisfies the constraint that x into y should be less than 0 because x is positive and y is negative. Once we get the initial solution, listing down the remaining solutions is a cakewalk. Remember, for equations like these, minus sign in between, when x increases, y also increases, and when x decreases, y also decreases. So we will increase x because decreasing x would result in a negative value for both x and y, which is not permitted by this constraint x into y should be less than 0. Right. Further, from one solution to the next, x increases by 5, which is the coefficient of y, and y increases by 8, which is the coefficient of x. So let me list down the solutions. They are x is equal to 2, y is equal to minus 41, 7, comma minus 33, 12, comma minus 25, 17, comma minus 17, 22, comma minus 9, 27, comma minus 1. We don't need to go any further because beyond this, both x and y will be positive. And again, this constraint, x into y should be less than 0, will not be satisfied in that case. Thus, there are 6 solutions possible for the given question. And now comes the killer question. As I mentioned earlier, if you have large coefficients for the variables, like in this case we have 13 and 17, you might need many iterations even for the initial solution. And this question is an example of that. Following the proper method for solving special equations is even more advisable here for such questions. So let us rewrite our equation first as we like it. Take the term with the bigger coefficient, which is 17y, to the right. The left hand side is 13x. It's a multiple of 13. So next we will extract all multiples of 13 from the right hand side as well. 643 can be written as 650 minus 7. Alternatively, I could have written 643 as 637 plus 6 also. It does not change my solution. Similarly, minus 17y can be broken into minus 13y minus 4y. Now we have to divide the whole equation by 13. And for the equation to balance, this fractional part should be an integer, which means 7 plus 4y should be a multiple of 13. Let's perform iterations for the initial solution. At this stage, I would like to teach you one more special trick, the trick of doing iterations faster. During the iterations, our objective is to get an integer value of y such that 7 plus 4y is a multiple of 13. And in the usual way of doing these iterations, let's call it method 1. We start with the smallest possible value of y, that is y is equal to 1, and try out next and next values till we get a solution, isn't it? For y is equal to 1, 7 plus 4y is equal to 11. 11 is not a multiple of 13. So in our next iteration, we take y is equal to 2. For y is equal to 2, 7 plus 4y is equal to 7 plus 8, that is 15. Again, not a multiple of 13. Next iteration, y is equal to 3. For y is equal to 3, 7 plus 4y is equal to 7 plus 12. That is 19. Again, not a multiple of 13. Next iteration, y is equal to 4. For y is equal to 4, 7 plus 4y is equal to 7 plus 16. That is 23. 23 is not a multiple of 13. So we take the next value of y. For y is equal to 5, 7 plus 4y is equal to 7 plus 20. That is 27. Not a multiple of 13. Next we take y is equal to 6. For y is equal to 6, 7 plus 4y is equal to 7 plus 24, which is equal to 31. Not a multiple of 13. And for y is equal to 7, 7 plus 4y is equal to 7 plus 28, which is equal to 35. Not a multiple of 13 again. Look at the pattern. The value of this expression, 7 plus 4y, is increasing by 4. 27, 31, 35 and so on. So next I can see there is finally a multiple of 13, the number 39. If we take y is equal to 8, 7 plus 4y becomes 39. It's a multiple of 13. So in our initial solution, after 8 iterations, we have a multiple of 13 finally. Great. So for y is equal to 8, x is equal to 50 minus 8 minus 3, which means x is equal to 39. Now before I come to other solutions for this question, let me quickly discuss method 2. This method is closely linked to our objective, which is the fact that for an integral solution, 7 plus 4y should be a multiple of 13. So what say? Let's try values that are multiples of 13 for this expression. Multiples of 13, by the way, are 13, 26, 39 and so on. Let us do that. In our first iteration, if we take 7 plus 4y is equal to 13, y is equal to 13 minus 7 whole upon 4. 6 upon 4 is 1.5. Clearly not an integer. In our next iteration, we try out the next multiple of 13. 7 plus 4y is equal to 26. Then y is equal to 19 upon 4. Again not an integer. And finally, in our third iteration, when we take 7 plus 4y is equal to 39, then y comes out to be 39 minus 7 whole upon 4. Y is equal to 8, an integer this time. So as you can see, this method requires only 3 iterations and is much faster than method 1. But it's up to you. You may follow whichever method you are more comfortable with. Now it's time to draw up the list of other solutions. The smallest value of y possible is 8. So let us increase y. And the pattern for special equation says that from one solution to the next, if y increases by 13, which is the coefficient of x decreases by 17, the coefficient of y. So y is equal to 8 plus 13, which is equal to 21, and x is equal to 39 minus 17, which is equal to 22. This is another possible solution. Next, y is equal to 21 plus 13, which is 34, and x is equal to 22 minus 17, which is equal to 5. This is yet another possible solution. Beyond this, if we decrease x by 17 more, it becomes negative. Therefore, there exist 3 possible solutions for this equation. So that brings us to an end of this video lesson. Hope the concept of special equations is crystal clear to you now. Just in case you want to practice few more questions on special equations, you may watch these video lessons on the topic. They are already there on our channel, and this one we are going to publish soon. That's about it. Thanks for watching. If you enjoyed watching this video and found it useful, do press the like button and subscribe our channel for related content. Here is a glimpse of other maths videos on our channel. Stay tuned and take care. Bye-bye.